Alright, so I think this is recording. Let's take a look at problem number 4 and see what we have here. It's asking us to find the domain. So the domain is a set of all real numbers, excluding any values that cause division by 0, also excluding any values that cause us to take the square root or even root of a negative number. I do not have any variables in a denominator for f, so I do not have to worry about division by 0. But I do have a variable that's underneath a radical, so I am concerned about taking the square root of negative numbers. I take this expression, this x plus 4 is representing some real number based upon the value of x. Well, I need this number to be 0 or positive. As an inequality, we say greater than or equal to 0. If I subtract 4 from each side, x needs to be bigger than negative 4. If you think about what that is on a number line, it's okay to plug in negative 4 into f because negative 4 plus 4 is 0 and the square root of 0 is 0. If I plug in a negative 3 or any value that's bigger than negative 4, I'll get a positive number. If I plug in negative 3 plus 4 is 1, square root of 1 is 1. But when I plug in numbers that are smaller, that are to the left of negative 4, a number like negative 5, if I plug that into the function, I have the square root of negative 5 plus 4. Negative 5 plus 4 is negative 1, and the square root of negative 1 is I with complex numbers. And we haven't worked yet with complex. You've seen them before, but we're working within the set of real numbers when we work with these functions. So that's why it's not in our domain. To describe this set in interval notation, we can't list all the numbers because there's infinitely many numbers in there, including all the decimals. What we can do is describe it using this notation that they have made up, that we use a parenthesis or a bracket to determine whether to include or exclude an endpoint. I want to include this endpoint, so I use a bracket. We write a smaller number, comma, a larger number. If I'm extending to the right forever, we use the idea of positive infinity, and we use this symbol. And since that symbol is not, there is no largest number, so there is no endpoint that I can write down. So I can just indicate that that's going on forever. This will never have a bracket around the infinity because you can't include that endpoint. There is no endpoint. Alright, so there's my answer for problem number 4, part A. Let's move on to part B, finding the domain of G. Well, it's the same considerations, you know. The domain is a set of all real numbers, excluding any values that cause division by 0, excluding any values that cause us to take the square root or even root of a negative number. We don't have any variables in a denominator, so we don't have to worry about division by 0. We do have a variable underneath the radical, underneath the square root. So this number 9 minus x has to be non-negative. It has to be 0 or positive. When we solve this inequality, I prefer to have my variables written on the left here. So 9 greater than or equal to x is logically equivalent to x being less than or equal to 9. So if we think about what that means on a number line, we include the expression, the value 9, because when we evaluate this function at 9, when we plug in 9, we have 9 minus 9, and the 0, and the square root of 0 is 0. The square root of 0 is well defined, so I'm going to include that. I want to have numbers that are smaller than 9 so that subtraction is a positive number. 9 minus 8, 9 minus 7, those are all positive numbers. A number like 10, 9 minus 10 is a negative number, and I won't be able to take the square root. So then to define, to write, to tell people what our domain is, we use interval notation as one way. a very common way, we describe this interval that's shaded here. We start with smaller values, so it doesn't get smaller than negative infinity. So negative infinity all the way up to positive 9, including 9. So there's my answer. There's the domain for G. Alright, so let's take a look at part C. The domain of the composition. So again, when you're finding domain, I'm not arguing, I'm not saying that it's always easy to find the domain, but I'm saying the considerations, the starting point is always the same. The domain is the set of all real numbers, excluding any values that cause division by 0, and excluding any values that cause us to take the square root or even root of a negative number. When you have a function composition, two things need to be true. And this needs to be true for any function, is your input has to be in the domain in order to produce an output. And it's the second part that makes these problems a little bit challenging, because now this output of this function G becomes the input into the next function F. And in order for a function to have an output, the input has to be in the domain of that function. G of x is the input. It has to be in the domain of F in order to produce an output. Now, so the thought process is always the same, and it's consistent. It's applying that to the different problems, and some problems are easier or harder than others. Let's take a look and see what we think about this one. So first off, for the domain of this composition, in order to be in the domain of G, x has to be, what did we say, less than or equal to 9, right? The domain of G, yeah, was less than or equal to 9. So we needed this x to be less than or equal to 9. And that might end up being our final answer. It all depends on if this F is going to require any more further restriction, because F might be picky and it might not like the output of G. So we might have to adjust the input to make the output tasteful for F. Okay, so this F, we said that its input, and I'm going to temporarily call that x, has to be less than or equal to -4, right? Now, F never sees the x. What I really want is G of x to be less than or equal to -4. And G of x is the square root of 9 minus x. And Lucy, we have a problem. Alright. That's never going to be true, because the output of G, I guarantee that the output of G, did I get that right with G of x? Let's go back and double check. It has to be greater than or equal to -4. And I put less than or equal. Okay, let's correct my error. Maybe you were yelling at the screen. Okay, that's better. Now, because otherwise we would have had an empty set. This G of x has to be greater than or equal to -4. G of x is the output of a square root, a principal square root. Hey, on the left side, it's always 0 or positive. So 0 or positive, hey, it's going to be bigger than or equal to -4. We're not going to have any problems with the output of G, because F will accept all of these numbers. F likes positive numbers. X will even accept a few negative numbers, all the way to -4. It'll take a -1, a -1.5, a 3.99. It'll take negative 4. It just won't take anything that is smaller than negative 4. And the output of G is always positive, so it's never going to be smaller than negative 4. So the only restriction that we have for this function composition comes from the domain of G. So the domain of this function composition is from negative infinity to 9, including 9, which was the domain of G. There's my final answer for problem 4, part C. Let's move on to part D. So again, it's another domain question. Domain is a set of all real numbers, excluding any values that cause division by 0, also excluding any values that cause us to take the square root or even root of a negative number. To find the domain of a composition, we need two things to be true. The input into our first function, which is always listed last in our composition notation, this input has to be in the domain of f. Otherwise, we will not have an output of the function. Now, in a composition, the output of this function becomes the input to the next function. And what has to be true is that this input, just like before, the input always has to be in the domain of the function. F of x has to be in the domain of G, otherwise we don't have an output. Alright, so our domain of I almost pulled off the headset off my head. I got stuck here. Oh, I'm so glad that that is not on camera, that you could not see that. Alright, the domain of f. Now I'm going to go back and look at my answer before because we saw that I couldn't remember it. Negative 4 to bigger than or equal to negative 4. I know that this has to be greater than or equal to negative 4. Now, the domain of G we saw had to be less than or equal to 9. But it's not that x is less than or equal to 9. It's that I need the input for G to be less than or equal to 9. The input for f was x, but the input for G is f of x. So I need f of x to be less than or equal to 9. Let's take a look at what f of x is. It is the square root of x plus 4 less than or equal to 9. Alright. I know that this is going to be a positive number. I'm concerned whenever I have an inequality, I've got to be careful to come in and just square both sides of the equation, you know, like I do with when I have an equal sign, an equality. If I have, I think I mentioned this in class, if I have negative 4 being less than negative 2, that's a true statement. If I come in and square each side, then I can't keep that inequality the same direction because 16 is not less than 4. So some of the properties that we have when we're solving an equation like this, where this is equality, some of those properties do not hold for inequalities, or at least we have to be cautious with them. Maybe I should say it that way. Alright, so since I know that this is positive, I don't believe I have any worries there. So I think that I can take the square root of each side. And when I square a radical, the radical goes away. When I square 9, 9 times 9 is 81. That's not right in the highlighter. If 81 minus 4, 77? Yeah. Alright. So we have to have the idea that x has to be bigger than -4, bigger than or equal to -4, but at the same time it needs to be less than or equal to 77, because if we picked a number like 78 will have no problem going through the function f. If we evaluate f at 78, then 78 plus 4 is 82, and we'll have the square root of 82. And the square root of 82 is a number that's bigger than 9. If I have a decimal, let's get a decimal point just to, because sometimes you look at square root of 82 and you're like, I don't know what that number is. But you look at a decimal number, 9.06. I've got this fixed to 2 decimals. So to 2 decimals, this is 9.06. When you plug that into G, the square root of 9 minus 9.06, that 0.06 is enough to make this negative, and this is undefined. I can't let 78 be in the domain of f, so that's why we've restricted it to be 77 or smaller. So my domain of this function composition, golf, has to be bigger than -4 to accommodate f, but it has to be smaller than 77 to accommodate g. So there's my answer. The domain for problem 4, part D, is the interval from -4 to 77, including both endpoints. I think that's it. Hey, I hope that helps. Talk to you later.